Hello student, my name is Benihadi Fraxon Masebo. I'm a senior mathematics teacher holding bachelor degree of education majoring mathematics. I have been sharing with you the topic of Form 5 and now we have gone somewhere with the topic of algebra. The previous session we also touched some advanced past paper Form 6 papers of some questions which were asked. Now today, I'm taking you where we ended with the part of algebra, and that was the part of remainder theorem, finding remainder using syntactic methods. So today, with the concept of remainder using static methods, we covered the concept of quotient remainder upon dividing the polynomial by another polynomial. So today, we will be starting the part of remainder theorems. So today we check the part of remainder theorems. Remainder theorems. Remainder theorems. So we say, instead of using long division methods, we can use the concept of remainder to determine the remainder directly without performing long division methods, which takes time, is too mechanical, and a lot of space. So to save time and space, and to be short enough in arriving with the solutions, we just go for the concept of remainder theorem. How it states? It says, given that P of x is divided by D of x, and giving the result quotient Q of x plus remainder R over D of x, then we say if D of x is an expression known as x minus a, we can now replace in the place value of D of x, and first of all, let us avoid this denominator. So we say then we have P of x equals to Q of x times D of x plus remainder R. So setting the value for D of x, which is x minus a, the function now becomes, the expression becomes P of x equals to Q of x, this time here x minus a plus R. So we say setting x equals to a, what is going to happen? Upon x equals to a, we now have the function P of a now equals to Q of a, and here becomes a minus a plus R. But with a minus a, this is 0, therefore making the entire part vanishing, therefore giving us P of a equals to R. We say hence remainder theorem. Hence remainder theorem. Now let's look how this theorem works. If you check carefully, it means with x equals to a, this is a result upon setting D of x equals to 0, solving for x in which x is giving a. So the remainder now, we can check the question like this. Let's look this worked example here. Worked example. Worked examples, it says, one says, find the remainder when an expression x power 3 5x square x plus 6 is divided by, let's say, x plus 4. Find the remainder. So here now, we simply perform the operation using remainder theorem. So we say solution to find the remainder here. Finding the remainder, we say solution, we say let P of x equals 2. So we assume this expression giving the name of a function. So x power 3 plus 5x square minus x here plus 16. And now we say and We have also d of x. Let's call this is x plus 4. So we say solve d of x equals to 0. Solving d of x equals to 0 here, what is going to happen here is simple. It is just giving us an expression x plus 4 equals to 0. Therefore, x giving negative what? Negative 4. This is the one assumed as A, just from our approach there. Therefore, to find the remainder, say p of negative 4 equals to, just plugging negative 4 here. Negative 4 times 4 is going to give negative 64, and here plus negative 4 here, 16. 16 times 5, this is 8, minus e, minus again, plus 4, plus 6 here. So summing these ones, 90. So it's negative 64 plus 90. This is the same as giving 26. So we say, which is the remainder direct? You can see how it is interesting upon dealing with this one. So it's so nice. So using this trick, it is really so easy, and for sure it saves time upon using these remainder theorems. Now you will be trying this one. One can say try this. Try this. Find the value of A and B if an expression x square x power 3 plus a x square plus b x plus c leaves a remainder of 2 when divided by x plus 1, and a remainder of negative 5 when divided by 2x, let's say, plus 3, something like that. Of course, just giving you the hint on this one, you could simply say, you could simply treat like this. You could say, let p of x equals to the function which we have been given, plus ax square plus bx plus c. This is supposed to be a certain, it was supposed to be 4 here, sorry. This is supposed to be 4. So this is plus 4. So we say, when it solving this divisor equals to 0, it gives negative 1. So we're going to get negative 1 power 3 plus a negative 1 square b power times negative 1 plus 4. The answer is this remainder 2. So you are going to have a minus b negative 1 becoming 3 to the other side going to become negative 1. So call this is equation number 1. Treat the same also. Gives the remainder of this when divided by this. Now solve the divisor again here equals to 0, where x now is going to become negative 3 over 2. Now putting this one for the function p negative 3 over 2 in this function, you will be getting another equation which is also depending on a and b by putting the result as this, which is a remainder, and hence out. So here we say easy to finish. Easy to finish. Okay, this is a concept of remainder. Now we are going to check with another portion, and this is a part of factor theorems. We're going to check factor theorems with the concept of remainder. What will happen if the function is exactly divisible without remainder? That is where it takes us to the part of factor theorems. So let's go. Okay, we now have the concept of remainder theorem when we were using remainder theorem, finding the remainder without performing long division methods. But now, when you are given an expression, we were given expression in form 2, like consider expression like x squared minus x minus 6. Let's say something like that. In form 2, expression like this one, it was easy to perform factorization by using splitting the middle term, which is just simple identifying our A here and B and C using splitting the middle term. Now what will happen if you will be given an expression like here we say factorizing this becoming x plus 2 and again x minus 3 equals to, no, this is just factorized. When one is giving us just a quadratic expression. But this time, when you are given an expression with an exponent beyond 2, let's say power 3, power 4, how can you perform it? That is where now we are forced to use, this concept is called the factor theorems. So we say to factorize an expression, is say ax power 3 plus bx squared plus cx plus d. Let's say like this. We say to factorize an expression like this. How do we perform? How do we proceed? We say we proceed as we use inspection method. We say we need a number, say, we can call this number, let's call it say P, such that if we could have this is P of x equals 2. We need a number, I can use another letter, let's call this R. I think, to make it easy, because the function is P of x. So, we need a number, say R, such that P of R equals to 0. It means, upon plugging the value of R, wherever there is x here, putting R, the function giving 0. But we say, how do we get that number? We say such number is obtained by inspection. It means by trial and error methods. That number is obtained by inspection, by trial and error to know the value of R. But we say, how many trials are you going to make? For sure it becomes so critical. It means you can be trying infinitely many numbers, and then you have an exam which is set with time interval. How are you going to finish up the paper? It becomes a challenge. That is why we say, despite the fact that the number is obtained by trial and error, and from the method which is referred as inspection method, still we need to know which numbers are the best one for trying. So we say the number worth trying, the number worth trying should be the factors of constant term. That is, for our case, number worth trying must be the factors of D. That means of D. Those are the numbers worth trying. And then that way, it has been tested mathematically, and it really saves time a lot. Now let's check worked examples on that. Worked examples. One can give us this, factorizing the following. Factorize the following completely. The following expressions, or just the functions, the following functions completely. Yes. We want to perform factorization for the expression completely. Suppose you have these questions here. One can give us P of x equals to 3x power 4 minus this one is giving 2x power 3, and here we have minus 13x square, and next we have plus 8x plus 4. Let's call this is A. B, one is giving us p of x equals to x power 3 less 1. C, p of x, one can give us x power cube plus 1. This was minus. We can also have this D, p of x. This one equals to x cube minus 3x square y. And no, sorry, this is not. This is supposed to be 7. Yes, 7. Yes, this is 7 x square y plus 7xy square. Yes, and then plus 15 y cube. Yeah, these are some counter examples for us to practice. Let us try to do just some selected ones. So here we say solution. Solution with A. It means numbers worth trying must be, we say, here we need a number A or number R such that P of R equals to 0. So we said the number worth trying must be inspection by inspection methods. So the number worth trying must be the factors of these 4. So here we say factors of 4 are plus or minus 1, plus or minus 2, plus or minus 4. So these are the number worth trying. So we start. We say try x equals to 1. So putting p of 1 here, p of 1, it means they are becoming 3. 1 power 4 minus 2, 1 is power 3 minus 13, 1 square, and then here plus c. It becoming 8 here times 1, it means plus 4. So with this, it means 3 minus 2 minus 13 plus 8 plus 4. So checking the result, you will find that when you take this 8 plus 4, 12. 12 and this 3, 15. And this 15, which is true, so gives 0. So we say, since x equals to 1 has accepted, it means we say, so x minus 1 is a factor. Since x equals to 1 has accepted to give 0, it means x minus 1 is a factor. So keep on trying as well. Suppose you put negative 1 also, trying negative 1. So you say try x equals to negative 1. So p negative 1. This one would be becoming 3. Put negative 1, so becoming positive 2. And there negative 1 minus 13. And there minus 8 plus 4. So checking for the result here. You say this one does not give 0. This is not giving 0, so that is not a factor. So try x equals to 2, let's say. P of 2. Trying x equals to 2, putting here 2 power 4, 16. 16 times 3. That is, because 2 power 4, 16. 16 times 3, 48. 48, yes, 48. And then put 2 here, 8. 8 times 2, 16, so minus 16. In the same way, putting here 2, that is 4. 4 times 13, so 52. So 52, this is minus 52. And then putting 2 there, 16 also, plus 4. So upon testing again, testing on the result, you could be finding that in negative 16 and 52 is 68. But when putting this one 4 and 16 is 20, and this 68, so this gives what? 0. It means again x minus 2 is a factor. It means we now have 2 factors. You just go with the same trend. For simplicity, you can keep on testing, but for simplicity, try to check also negative 2. So here we say, try x negative 2. So p power negative 2 equals 2. When putting negative 2 here, so this is 60. It will also be giving the same result. That is 48. 48. But negative 2, with this case here, is going to give negative 8, and this 2 plus 16. 16. So plus negative 2, that is positive. So 4, 52. But this is what? Minus 52, positive, because of negativity. But when you are coming again with this, is giving negative 16 with this plus 4. So checking this expression, it is this one, when you bring this and this, is negative 68. And that one, so this one also giving what? Gives also 0. The same result gives also what? 0. Now we are in the position to conclude that x plus 2 is a factor. So we have 3 factors at the moment. Now to find the third factors, how do we proceed? We just perform long division methods. It means take our factors. One of the factors was what? The first factor. Testing from our result, x minus 1. Another one, x minus 2, x plus 2. So we try to expand this. This becoming x squared minus 4, and here x minus 1, expanding x power 3. Again, this time this negative x squared, 4x plus 4. So when you make these ones, we will have to perform long division methods to get another factors. So performing long division methods here to get our result, that is easy to operate, because we simply bring, performing long division, we simply bring here our original function, which is the 3x power 4 minus 2x cubed, and next minus the 13x squared, and then we have 80x, and the other one plus 4. With this one we have x power 3 minus x squared minus 4x, and then plus 4. So we check which numbers must be set here from the polynomial. That must be x, 3x. 3x times here, so 3x power 4. And here now is minus 3x power 3. Bring here is negative 12 x squared. Next is 12x. So bring the division sign, minus here, cancels. Here becoming x power 3. And here becoming negative x squared. And next here becoming negative 4x. Finally is 4. So which numbers? Plus 1. 1 is here, which is going to give the same result. So x squared minus 4x plus 4. So with this result, what do we deduce from this one? Upon performing subtraction here, so giving the entire result vanishes. So factorizing, it means becoming x minus 1 factorization. Again, we have x minus 2. Another part here then. With this one, you will notice that, so you are just taking this and the product here. It means x plus 2 and x. Now this must be the first factor, 3x plus 1, hence factorized. You can see how it is interesting on this part. It has been so precious to perform this. So in form 2, we could not manage to factorize using this trick. We call it using factor theorems to perform factorization, which is conversely to form 2, which we were using separating the middle term. So let's check this. Another example. I'm going to treat B and D for the purpose. Let's go. Okay, now we have this one. We have seen how it could be factorized with B, which you have seen the conclusion. The conclusion was x minus 1, x minus 2, x plus 2, and that was 3x plus 1, completely factorized. But now let's check with B. Solution with B, we say B. Solution. With B here, this was simple. P of x equals to x cubed minus 1. So here we say, which numbers you can put to make it? We say plus or minus 1, factors of this number. So let's try 1. P of 1 equals to 1 cube minus 1, which is 0. We say so x minus 1 is a factor. X minus 1 is a factor. Now, having seen that, it means it is not easy to find the other factors since only one number has been obtained. So we must perform long division methods here. It means x cube 0x square 0x minus 1, and here we say x minus 1. So x square here, x cube, and so giving 0, this time this, negative. So this is going to be, yes, negative. This is supposed to be negative, we can say minus x square. This is supposed to be negative. This does not hold. So with this one, drop then here. So have 0x, we have something like 0. Just supportive number. They have no significance. Minus this goes, subtracting this becoming x square, and then plus 0x minus 1. Which numbers to be treated here? This is supposed to be x. X times x, x square minus x. Subtracting it goes, here becoming positive x and minus 1. Which numbers here? Plus 1, x minus 1. So subtracting, it just goes. So to factorize, it means p of x, this becoming x minus 1, x square, it means this result, plus x plus 1, completely factorized. This is how one could factorize this. So let's check with this d. You know, C is just a reflective concept of B, so you could be using the same trick. So let us now check with the part of D how one could perform this factorization. Let us check on this. Okay, so here we say, first of all, we must be taking this D. What is the most trick here? You must check we say the constant numbers, constant factor, constant term we say of D. Constant term here, when you take this is a polynomial about x, so the constant term becoming 15y cubed. So we say with D, constant terms, we say factors of 15y cubed are, here there exist many factors, because you'll be taking plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15, plus or minus y, plus or minus 3y, then plus or minus 5y, plus or minus 15y, again plus or minus y square, plus or minus 3y square, plus or minus 5y square, plus or minus 15y square. We will be also having plus or minus y cube, plus or minus 3y cube, plus or minus 5y cube, plus or minus 15y cube. Oh, student, you can see how it is challenging. It means using trial and error methods, which is our inspection, trying to plug each of these ones in the given function p of x such that the function is giving 0. You can imagine it is really a challenge. So you must have been tested carefully. So I have already tested this one. Here, one of the numbers to try, I'm going to try purposely in particular to give the result. Okay, I have tried this one. With our question, we say, try x equals to negative y. It means p of negative y equals to, plugging negative y wherever there, so negative y cube, and here it says minus 7 negative y square times y, and here plus 7 x negative y, and we have y square, and then finally 15y cube. Treating this carefully, gives negative y cube, gives negative 7y square, and then this gives again what? This this is supposed to be y cubed, sorry, because y squared times y, and it gives negative 5y, 7y cubed, and here 15y cubed. Checking on this gives what? 0. We say, so x plus y is a factor. You can see this trick. Trying again. Here I tried with him, try x equals to 5, 3y. This one, p of 3y, this was also giving 0. It means x minus 3y is a factor also. In the same way, I have given the count example how you could proceed. Try again, x equals to, I have already tried here 5y. This one also giving p of 5y, giving 0. It means x minus 5y is a factor. So making rearrangements with all factors, it means we say, therefore, p of x equals to, with our factors class, x plus y, again we have x minus 3y, and next we have x minus 5y, hence factorized. You can imagine how it is interesting. I could not teach beyond this with the part of factor theorems. You can see how it is interesting. We are going to check for the next part, which is extended factor theorems. Okay, we are taking a short break. But before we go, let me remind you, with any challenge or any question you are asking, or any advice, send us a question through WhatsApp of the number 0769048594. You can send a message through WhatsApp or just messaging from that number. And in Instagram, follow us in Instagram in Elimika Darasa. With YouTube, with YouTube, follow us in the part of Elimika. Thank you very much. We are taking a short break. We will be right back. Don't go away.